Okay, good morning guys. Hope we're doing well. This is going to be hopefully a quicker video. We're going to talk about both tangent and cotangent graphs, and then you've got a worksheet where you can practice your skills at getting better with them. Alright, so here we go. So just as a reminder, let's remember that tan x, right? Tangent of x, that's really the same thing as sine x over cosine x. Okay, so one of the reasons this is important is because we can analyze really in some ways just the top, the sine x characteristics, which we know from a couple classes ago, and the cosine x characteristics. Okay, here you've got a graph of tangent, right? And so it looks very different than sine or cosine. It still has this repeating pattern, right? But now, if you notice, it's got some vertical asymptotes. Okay, so they're not explicitly drawn, but our knowledge of rational functions will come in to play when we're graphing these tangent or cotangent graphs. Actually, so might as well talk about this now. So we've got a denominator, cosine of x, right? Cosine of x is 0 when x is, let's see, pi over 2, 3 pi over 2, and also negatives, right? So we know from rational functions that if we've got a denominator that equals 0, and it doesn't factor out with the numerator, which this doesn't, we have a vertical asymptote. All right, so this vertical asymptote right here, this is x equals pi over 2. Okay, and if we look, this is, here's 1, here's 2, so this is about 1.57. Okay, the next one, the asymptote here, is going to be at 3 pi over 2. All right, so I'm gonna plot that also. So that's roughly, I don't know exactly, but I'm going to put it there. X equals 3 pi over 2. Okay, and now another change too is, well, this is one complete cycle, right? After this, when I jump over this vertical asymptote, I have a repeating pattern. Okay, so what that means is our period now is pi. It's not 2 pi anymore. If you want to think about another reason why that is, well, if we look at the unit circle and we're measuring an angle, here we have sine positive, cosine positive. In quadrant 2, we have sine positive, cosine negative. In quadrant 3, they're both negative. Okay? If they're both negative and tangent's the ratio of them, well, then all the tangent values here are going to be are going to correspond to tangent values over here. Now the angle has to obviously be the same or similar, but that's another way that you can think about why tangent starts to repeat after pi units, right? Because over in quadrant 3, all these values are going to start matching up with values in quadrant 1. Okay, so this huge thing to remember: the period is pi. Okay, your asymptotes are in general are at this general solution, right? Pi over 2. So that's where we started here. And then this plus or minus n pi, well, what this is doing is this adding a multiple of the period of tangent, which is pi. So if I take pi over 2 and I add pi when n is 1, I get 3 pi over 2. If I make n equal to 2 and I take pi over 2 plus 2 pi, well, that's going to be 5 pi over 2. So this next asymptote over here, this is going to be at x equals 5 pi over 2. All right? And we could also do the same thing going to the left into negative angle values. Hopefully that makes a little bit of sense. A couple other things, the range of this is all real numbers. We see that from the graph. This is unbounded, right? This thing's going to continue going up forever, and it's going to continue going down forever. And then the domain's a little bit weird, so what we're going to do is we're going to take out the places where the vertical asymptotes are. So we're going to say the domain is everything except x can't be pi over 2 plus or minus n pi. All right, let's get on to this next page, then I'll cut the video and we'll look at some examples. So we're talking about tangent. Well, we know that we've got a reciprocal trig function called cotangent that's very related to tangent. Here's its graph, right? So a couple things to notice is it's decreasing always, right? It's always decreasing. Tangent, this red graph here, is always increasing. Okay, we'll get to y in a second, or maybe a couple seconds. So for cotangent, one cycle occurs between 0 and pi, right? So here's x equals 0, here's x equals pi for cotangent. That's one full cycle. After you jump over, you got a repeating pattern, right? You got a second cycle. This is actually cos x over sine x. Okay, so another thing that's useful besides the vertical asymptotes is zeros, right? Zeros. So if cosine of x is equal to 0 in cotan, well then this whole fraction is equal to 0. So I've got a 0 at pi over 2, I got a 0 at 3 pi over 2, I got a 0 at negative pi over 2, etc. Okay, the asymptotes of this graph actually occur when sine of x is equal to 0. So that would be at 0, at pi, at 2 pi, etc. Okay, so there are vertical asymptotes at each end of the cycle. The asymptote occurs at pi, the asymptote that occurs at pi repeats every pi unit. So it's the same idea, right? When x is 0, the sine of 0 is 0, so cotangent has a vertical asymptote, whereas tangent has a 0. Okay? Maybe one other thing to remember is this is actually equal to 1 over tan x. So if I have my tan x graph, when tangent of x equals 0, well, 1 over 0 is undefined, so cotan has a vertical asymptote. When tangent of x is undefined, right, that means the values are going to infinity or negative infinity. Well, 1 over that is basically 0. So when tan x has a vertical asymptote, cotan x has zeros. I'll let you read through the rest of this stuff on your own, okay? So maybe pause the video now. See if you agree with all those characteristics there. And I'm actually going to stop it now because I think we have examples next. Yeah, so a lot to absorb, but I promise you it's going to make a lot more sense very soon.